The purpose of this video is to recap all things linear. Really, we're going to talk about different forms of the equation of a line. We're going to talk about intercepts. We're going to talk about slope. We're going to talk about function notation a little bit. We're going to briefly talk about parallel and perpendicular lines. And we're going to wrap up by reminding ourselves how to graph a linear equation and extend that idea just a little bit further to absolute value. So I hope you find this video to be a great review of things that you likely already knew. The purpose of this video is not to teach you something brand new, but to freshen up some skills that you have learned in previous classes. So here we go. All right, so what are the things that we already know about lines? Well, we know that we use the letter M for slope, that our slope is our rise over our run, or our change in y over our change in x. We know that in a linear function, this slope is constant. We know that positive slopes go upward, negative slopes go downward. We know that horizontal slopes, or we know that when the slope is 0, we have a horizontal line, and that we have an undefined slope if we have a vertical line. And just as a reminder, a horizontal line would look like y equals a number with no x, and a vertical line would look like x equals a number with no y value. A horizontal line is a function, as are lines with both positive or negative slopes. However, a vertical line is not a function since it doesn't pass the vertical line test. And we know that in order to write the equation of a line, we need the slope and a point, or 2 points. The two key forms for writing the equation of the line are point-slope form and slope-intercept form. There's another form called standard form, but its definition varies heavily from one book to another book. These are the two forms that you're going to be using primarily, and that's what I wanted to focus on. Let's first talk about point-slope form. Point-slope form is y minus y1 equals m times x minus x1, or times the quantity x minus x1, where m is still our slope, and x1, y1 is a point on the line. This form really just comes from the slope formula, right over here. If you actually just solved for y2 minus y1, or if you shifted the subscripts around a little bit, you get to point-slope form. But the idea here is if you know the slope and you know a point, whether or not that point is the y-intercept, you could easily write the equation of a line in point-slope form and stop, and you'd be done there. Right after you plug in m, x1, and y1, you have written the equation of a line. Now, slope-intercept form is the one that most people are incredibly familiar with. Y equals mx plus b, where m is still our slope, and b is the y value of our y-intercept. In earlier on classes, we spend a lot of time working on slope-intercept form because we're interpreting often what that y-intercept is, or it's helpful for us to have that value, and it's great to have something in slope-intercept form. However, for the purposes that you're going to use in calculus and higher level maths, point-slope form is just as useful as slope-intercept form. So know that it's acceptable for you to stop at point-slope form unless the directions tell you otherwise. So let's recap finding the slope a little bit, and then let's work on finding the intercepts of these 6 problems below. Okay, number 1 is currently in slope-intercept form. It's in the form y equals mx plus b, so I can identify what my slope is. My slope is that number here, 3. I can also identify my y-intercept, which is the point 0, negative 2. The directions here also, they say find the intercept. So just as a reminder, intercepts are points on the axes. So the y-intercept is the point that we get when x is equal to 0. The x-intercept is the point that we get when y is equal to 0. So we can identify the y-intercept solely from just using slope-intercept form. To find the x-intercept, we need to plug in y equals 0 and then solve for x. So 0 equals 3x minus 2. Add 2 and divide by 3. We're going to get that x equals 3 over 2. And if I was going to write that as an ordered pair, 3 over 2 comma 0. So this is my x-intercept. my y-intercept, and our slope. All right, number 2 only has one variable. Y equals -5 is a horizontal line. That means that my slope is 0. If y is equal to -5, then regardless of what x is, 1, 2, 3, 4, 5, regardless of what x is, y is equal to -5. So the y-intercept is going to be 0, -5. There is not going to be an x-intercept because this is a horizontal line that is below the x-axis, so it will never cross the x-axis. So there is no x-intercept. Number 3. Now, on number 3, there's a lot of different things you could do. You could translate this equation to be in slope-intercept form, and then you could identify the slope and the y-intercept, and you could do exactly what we did on number 1 to find the x-intercept. That's a totally logical strategy. What I'm going to do is what I would have done in Algebra 1. I'm going to find the x-intercept. That happens when y is equal to 0. If y is equal to 0, then I would have 2x is 6, so x equals 3. So the x-intercept is the point 3, 0. To find the y-intercept, I would plug in x equals 0, so -3y equals 6, which means that y equals -2, which means our y-intercept is the point -2, 0. So y-intercept, x-intercept. How do we find the slope? Well, we have 2 points. How do we find the slope with 2 points? We use the slope formula, y2 minus y1, which in this case, -2 minus 0 over x2, 0, minus x1, 3. This is going to give me -2 over -3, which is positive 2/3 would be our slope. Now I encourage you to pause the video and work through 4, 5, and 6 on your own, identifying that slope, identifying the x-intercept and the y-intercept, and if you get stuck, you can unpause the video and I will walk through them with you. But challenge yourself and see what you can figure out on each of these 3 remaining problems here. So hopefully you've had some time. X equals 7 is a vertical line. That means that my slope is undefined. My x-intercept is going to be this point right here, which would be 7, 0, and there isn't going to be a y-intercept because it's never going to cross the y-axis. Number 5. I'm hoping that you did not distribute and put this into slope-intercept form because you really didn't need to. We can immediately tell what our slope is. Our slope is 6. This is point slope form, and slope is that number in front of the parentheses in point slope form. So I have my slope. I also have a point, which is the point -1, +5. Now that point doesn't really help me, but if I was graphing it would, and we will review that in a few minutes. How do we find the x-intercept? We plug in 0 for y. So that would give us -5 equals, and I am going to distribute now, 6x plus 6. And if we solve this out, we're going to get that x is equal to -11 divided by 6. If I subtracted 6 and then divided by 6. So the x-intercept, -11 over 6, 0. The y-intercept is what we would get when x is equal to 0. So y minus 5 would equal 6. Add 1 to both sides, so y is 11. So our y-intercept is the point 0, 11. So we have our intercepts and we have our slope. Now, if you need more time to look over any of those examples, go ahead and pause the video because number 6 is going to take a little bit more space than I think I have. So I'm going to erase what you see on the screen and move this page around a little bit. So pause the video if you need to. All right, I probably don't need this much space, but that's okay. Let's find our slope first. So y2, -3 minus y1, -4, over x2, 6 minus x1, -2. This is going to give me +1 over 8. Now to write the equation of a line, I need a slope and a point. And in order to be able to find the x and y-intercept, in order to be able to plug in 0 for x to find the y-intercept and 0 for y to find the x-intercept, what we need to do first is we need to actually have a place to plug them in. So we need to write the equation of the line next. So this was definitely a challenging one, which is why it was the last one here. So I'm going to pick this point right here. So y minus -3 is going to become y plus 3 equals my slope times x minus 6. And I'm going to go ahead and find the x-intercept, which means that I'm going to plug in 0 for y. So 3 equals, I'm going to distribute, 1/8 x minus 6 over 8, or minus 3 over 4. And now I'm going to solve for x. So I'm going to add 3/4 to both sides. Just as a reminder, if I'm adding something like 3 plus 3/4, 3 and 3/4, right? Multiply 3 times 4 to get 12, add it to 3 to get 15 over 4. And instead of writing 1 over 8 times x, I'm going to write x over 8 so that I can cross multiply. 15 times 8 equals 4x. 15 times 8 divided by 4 is going to give us 30. So our x-intercept is 30, 0. And it's okay if you needed to take some more steps and show some more work, but I really just want to focus on the intercept portion here. Now, to find the y-intercept, we're plugging in x equals 0. So we're saying y plus 3 equals 1/8 times 0 minus 6. Y plus 3 equals negative 3/4, since this would be 0 times, 1/8 times negative 6 is negative 6 over 8, which is negative 3/4. And then we would subtract 3, and that's going to give us negative 15 over 4. So the y-intercept would be 0, negative 15 over 4. So now that we've spent some time reviewing slope and finding intercepts, let's spend a little bit of time reviewing writing linear functions or writing linear equations, and also tie in a little bit of function notation that you may or may not be familiar with that we need to sort of refresh. So number 7 is asking you to write a linear function using 2 points. So go ahead and pause the video and do that. Hopefully you did that already on number 6, and this one is going to seem more straightforward. Then unpause the video when you're ready. All right, hopefully you had time to do that. We're going to find our slope first, 4 minus 2 over negative 1 minus 1, which is going to give us 2 over negative 2, which is negative 1. It doesn't specify what form, so I'm going to write this in point slope form. So y minus the y value of that point, which is 2, equals my slope, which is negative 1, or just negative, times x minus the x value of that point. This is a totally acceptable answer. Now, some of you may have plugged this slope into y equals mx plus b, plugged the point in and solved for b. That's fine. You could have also used the other point, which would give you y minus 4 equals negative times x plus 1. You could have gotten it into slope intercept, which would give you negative x plus 3. All of those forms are acceptable. If this problem specifically asked you to use function notation, you would have to put it into slope intercept form so that you could write it like this. This is the way to have it in function notation. Okay. Number 8 looks incredibly different, although I'm hoping that you can see, even though this first part might scare you a little bit, that this is a very pleasant piece of information. We have been given our slope, and what do we need in order to write the equation of a line? We need the slope and a point. We have the slope, and believe it or not, we have a point. What does f of 0 equals 5 mean? It means that when x is 0, the function output is 5. So we do actually have a point. So what you're using that first statement for is to translate that into a point. When x is 0, the output of the function is 5. So we could write this as y minus 5 equals our slope 3 times x minus 0, or just y minus 5 equals 3x. Or y equals 3x plus 5. All of those would be acceptable. Since we were originally given this using function notation, the best answer would probably be to have your final answer be in function notation as well. Again, the directions don't specifically say you have to use function notation here. All right, go ahead and pause the video and see if you can dissect the information that you're given on number 9 and work through that problem, and then unpause the video and see how you did. All right, this statement here is giving us the ordered pair 3, 2. This statement here is giving us the ordered pair 5, 1. Let's go ahead and calculate our slope. 1 minus 2 over 5 minus 3 is going to give me a slope of negative 1/2. So I'm not going to write this in all of the different forms. I'm just going to use this point here. So y minus 2 equals negative 1/2 times x minus 3. Again, you could have used the blue point instead. You could have expanded it out and written it in slope-intercept form, but I'm just going to stop right here. So we've recapped slope, writing the equation of a line, intercepts. The next thing we're going to review are parallel and perpendicular lines. So what do we know about parallel lines? Parallel lines have the same slope. We would say that line K is parallel to line L. That's the notation, that symbol there. And that parallel lines never cross. Since they have the same slope, they never cross. What do we know about perpendicular lines? We know that they intersect at a right angle, at a 90-degree or right angle. We know that the notation would say line J is perpendicular. It's like an upside down capital T to line K. And you may or may not remember this, but we know that their slopes should be opposite in sign and reciprocals. So, for example, for perpendicular 1/2 versus -2. Those are opposite in sign and they are reciprocals of each other, which also means we talk about in Algebra 1 that their slopes multiply, or the product of their slopes is -1. So let's look at this example here. Given the line y equals 2x minus 4, so I'm going to already identify my slope since this is in slope-intercept form. So my original slope here is 2. Write the equation of the line parallel and passing through this point. So parallel line means that my slope will be the same. So that means my slope will still be 2. And they're giving us the point -1 and 3/5. So y minus the y value of that point is 3/5 equals my slope 2 times x plus 1. So here is my parallel line. Why don't you go ahead and pause the video and find the perpendicular line. All right, so we're using the same point to write the perpendicular line. So my new slope is not going to be the same as 2. It's going to be opposite in sign, so it's going to be negative since originally my slope was positive, and the reciprocal, which is 1/2. So y minus 3/5 equals -1/2 times x plus 1 would be my perpendicular slope. So if you need to go back and rewatch any of that, go ahead and do that. We're going to do this little practice on the bottom to make sure we understand the relationships with the slope, which is really the most important part since we already talked about writing the equation of a line. All right, the directions here say fill in the slopes for each function in the table below, given that f of x is parallel to g of x, so these two are parallel, and perpendicular to k of x. So I encourage you, if you're feeling confident, go ahead and pause the video and see if you can work through this on your own. So f of x and g of x are the same. They have the same slope. So I'm going to go in and anywhere that I have the slope for f of x or g of x, I'm going to just make sure that they are the same. So 2 and 2 are the same, or -1 and -1 are the same. Now, perpendicular means opposite in sign, and the reciprocal of 2 is 1/2. Perpendicular for the second one here, opposite in sign would be +1. The reciprocal of 1 is still 1. So my perpendicular slope for k of x in the second situation would be +1. In the last situation, I am given the perpendicular slope, so I need to change the sign, which would make it positive, and I need to flip that fraction over to find the reciprocal, which would make it 2/3 for both of those. So hopefully you can look at a slope and identify what that parallel slope would be, or what the slope of a line parallel to that line would be, and what the slope of a line perpendicular to that line would be. And we're going to spend some more time on function notation in a different section. Let's lastly move on to graphing. So if we are graphing a line, and yes, we are going to graph something else in this section as well, make sure that you identify the slope and a point so that you can first plot that point and then move your rise and your run based on that slope. Don't forget to use a straight edge, and don't forget to have arrows on the ends of your line. All right, so number 10, identify our slope, -3, identify a point, 0, 5. Plot the point. My rise, I'm going down 3 and I'm going to the right 1. I always go to the right 1 I always go to the right until I run out of space. So down 3, right 1, down 3, right 1, down 3, right 1. Now I would use a straight edge, but that's going to be difficult on my iPad. So you should be using a straight edge, and I'm just going to do the best that I can here. And I'm going to make sure I have arrows on the ends. Why don't you go ahead and pause the video and work through number 11 on your own. So we have a slope of -1/3, so down 1, right 3, and we have the point 0, -2. So I'm going to plot my points, and then I'm going to connect the dots and make sure I have arrows on the ends. And there we go. So when you are graphing the equation of a line, make sure that you find the slope, a point, plot the point, use the slope, connect the dots. Make sure you have arrows on the ends. Now the last thing we're going to talk about is actually graphing an absolute value equation, and how absolute value is really just two different lines together in one function. So here I have two absolute value equations, but let's actually just, before we jump into graphing these, let's talk about absolute value a little bit. Absolute value, the symbols mean do whatever is inside and then make it positive. Hopefully that is something that is familiar. So if I had the absolute value of -3, that would really be +3. When we graph an absolute value function, as you have hopefully done in previous classes, we get a V-shaped graph, or an upside down V-shaped graph. The reason being, everything inside is going to be positive, or if I had a negative in front, negative. That's how I could get one of these graphs pointing downward, until I get to that point, and that point is whatever would make the inside of the absolute value equal to 0. Because at that point, I can't make 0 positive. 0 is just 0. So key things to know about absolute value. Absolute value is really just two lines in one graph. I have a line here, or I have part of a line, or I have a ray since it stops there, and I have a line here. I'm going to say two lines or rays. I guess that's a better word to use there. What do you need to do when you're graphing absolute value? You need to identify what makes the inside 0. What makes the inside number, or what makes the inside of the absolute value equal 0? The reason is you are going to split at that number. That way you can rewrite your function. So what do I mean by that? Let's look, I'm going to create a little example down here. Let's look at an example. Let's suppose that g of x is equal to the absolute value of 2x plus 1. So I want you to ask yourself, what makes the inside equal 0? And hopefully without having to do any work, you can figure out that 1/2 is that magic number that makes the inside equal 0. When we create a piecewise function, which is something we're going to focus on more in another section, but that value that we just found is going to be the value that we split our function at. So -1/2 is my piecewise function value. It's the value that changes things. So what I mean by that is if I was graphing this function, it's going down, 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 down until it gets to -1/2. At -1/2, it's 0, and it starts going back upward. So let's think about the left-hand side of that graph. The left-hand side of that graph is the opposite of whatever is inside there, because it would be negative, but the absolute value is making it positive. The other piece is just what you see in the function without absolute value. So when you split it into two pieces, you're going to be taking the opposite of what's inside as we go to the left, and what's inside as we go to the right. So we're going to focus on this more in another section, but for purposes of graphing, I think this is going to help us out. So looking at number 12, the first thing I want you to do is split this into a piecewise function. What's the magic number that makes the inside 0? That magic number is -1. If I plug in -1, the inside would be 0. So this would be the opposite of what's inside. So the opposite of x plus 1, which is the same thing as -x minus 1. And x plus 1 would be the other piece of our function. So the magic number, -1, gives us 0. So that's the vertex. And then think about what's happening here. I'm going to look at this piece first. Up 1 over 1, up 1 over 1, up 1 over 1. And then our other graph is doing the exact same thing, except the absolute value is making it reflect over in this way. And then we can connect, hopefully straighter than that using a straight edge. So go ahead and pause the video and first focus on finding the piecewise function for number 13. All right, that magic number should be 3 over 2. This would be the opposite of 2x minus 3. This would be 2x minus 3. Sorry, that's so sloppy and squished. So 3 over 2 is going to give us 0. So that would be about here. And again, we're looking now, our slope is 2. So up 2 over 1 would be about here. Up 2 over 1 would be about here. And we're going to reflect that back the other way. Up 2 over 1. Up 2 over 1. And connect. So I'm sure that I lost some of you in this absolute value talk. The main goal of this lesson is really focusing on reviewing those linear ideas. This absolute value is an extension, and I'm going to support you more on this. So write down any questions you have, and I look forward to supporting you. Thanks for listening.